Alright, here we go. Welcome. So we're going to learn today about Riemann Sums, which is the area underneath the curve. So we just learned about slopes, and we're going to do the opposite of that, which is the area underneath the curve. Now I must ask you, how would you estimate the area underneath the curve? Rectangles. That's a phenomenal answer. Great job, class. So, like for an example like this one right here, it says approximate the area from 0 to 4. So, like this one is like from 0 to 4. In there, to approximate the area, we have 3 different ways that we can draw rectangles. So this says left Riemann sum, which means that we're going to go to the left interval and go all the way up until I touch the curve, and then I just draw it over, and that's my first rectangle. I do the same thing from 1 to 2. Draw the next rectangle. And I do the same thing until I get all the way over there. So I can find the area of those rectangles. Now this function doesn't give us actual values like here and like all these points. I don't really know what the exact height is, but that's really the general idea of it. Okay? And again, it says we're going from 0 to 4 using 4 equal with rectangles, which means how many rectangles do I actually have? 1, 2, 3, 4. Okay? That's a left Riemann sum. What do you think a right Riemann sum is? So I'm going to start at the right. So again, from 0 to 4, I'm going to start from the right and go all the way up and then go over this way. So what do you notice about left Riemann sum? How accurate is that answer going to be? Is it going to be above the correct answer, below, or exact? It's an underestimate. Why is that? Because it's less. So what's the right Riemann sum? It's going to be an overestimate. So let's come down here. So I don't know why this is in the very bottom, but it is. So it's an approximation more or less than the actual area. So if a function is constantly increasing, that's what we have. If a function is strictly increasing, then a left Riemann sum is going to be an over or underestimate? Underestimate. A right Riemann sum will be an overestimate. You're going to get some problems that are going to ask you like free response. Like they'll say, hey, find the Riemann sum, will be like part A. Part B will be this is an overestimate or underestimate and justify why. You just need to say like 2 things. So if it's like a left Riemann sum and it's increasing, you would say underestimate because left Riemann sum increasing. That's it. You just need to write those 3 things down. I don't need any sentences, Jonah, of whatever the heck you write about. I just want 3 words, not a paragraph, Jonah. Or like a whole story about whatever's going on. Less is more. Okay? What about if it's decreasing? I gotta use your imagination a little bit here. So if we're decreasing, left Riemann sum is going to be in overestimate. I'll show you why in a second. And then a right Riemann sum is going to be in under. Bless you. Okay, so like here's a function that is decreasing. So if I do left Riemann sums, you can see how the left Riemann sum is an overestimate. Okay, so this is left decreasing. And this is why this is an overestimate. Do you want me to draw the other way? Or we're good? Okay. So somebody was like, alright, if the left is an overestimate and the right is an underestimate, depending on which situation, is there something that we can do to be a little bit more accurate? This person came up with, okay, let's do a midpoint. So you go to so here are your 4 rectangles we're eventually going to draw. Right? So now we go to the middle, and the middle is going to touch. So you can see that we're a little under, but over here we're a little bit over. So it's kind of like compensating. So a little under, a little over. So that's what you do from midpoint. And there is a fourth one. I don't know if we'll talk about it today, but fourth one would be trapezoids. So you can also draw trapezoids, which would be, I don't think it's more accurate than midpoint Riemann sums. Just depends on the situation, on whether it's more accurate or not. Depends on what's going on with the slope. Alright, so that's kind of what we got. So I know I kind of ignored the stuff like above here, but all you do is the area is just when you add up all of those rectangles. So those aren't blanks for you to fill in. That's what you do to solve this. Okay. So Riemann sums, we use them to estimate in word problems. We see Riemann sums in word problems more than with the table typically. And you're gonna get estimating distances or area or total cost or just sums in general of rectangles. And again, it's going backwards from a derivative. Okay. So let's talk about position, velocity, acceleration. Okay. If I gave you the velocity, a velocity graph, what does the area represent? Represents the displacement. Okay. Now, if it's strictly increasing, it actually represent the distance traveled, right? As long as you don't ever go backwards. So yeah, it represents the displacement. So that's why it's an antiderivative. You got to represent it for going backwards. So it represents displacement as position. So the antiderivative of velocity, finding the area, which gives you position. Alright. So I'm going to kind of ignore number 1 right now because it doesn't give us enough information. You're not really going to see that very often. I'm just going to go right to number 2 because I like number 2 because it gives us actual real life stuff that we can deal with. Okay. The rate at which oil flows out of a pipe in gallons per hour is given by a differentiable function r of t, where 0 to 15 that's where t is between. Use a left Riemann sum with subintervals indicated by the table below to approximate the total amount of oil that flowed out of the pipe from 0 to 12, and let's indicate our units of measure. So it doesn't necessarily tell us how many subintervals. It just says look at the table and you figure it out. Okay. So this is going to be a left Riemann sum. I'm going to draw this. I'm not going to draw it every time. Some people like the drawing. I tutor people and I taught people before. Half love the drawing. The other half like to go right to the formula. Okay, so I'm going to show you each way. So I'm going to kind of sketch this guy out right here. Okay. So here's 3. Here's 6. Here is 9. 12 and 15. Okay. So what's the height at 3? Okay, so this right here is going to be 10.4. So here's the height right there. What's the height at 6? 8.10. 10.8. I'm going to really kind of stretch this so you can see the difference between them. What about at 9? So this is going to be 11.2. This is not to scale. Deal with it. What about at 12? 11.4. And then what about at 15? 11.3. So it'll kind of be in between them right there. Okay? So with a left Riemann sum, I'm going to start on the left and start making my rectangles. Okay? So make this rectangle right here. Make this rectangle right here. Make this rectangle right here. And this rectangle right here. So a left Riemann sum actually ignores what? The furthest right point. It's going to be the same situation we do a right Riemann sum. I'm just going to ignore that for this left point. So now let's kind of go through this. What's the width of this rectangle? It's 3. And then what's the height of this rectangle? 10.4. So what's the area of this? Isn't this just going to be 3 times 10.4? And we can do that in just a second. I just want to just kind of write this all out for you. Okay? What's the area of the next rectangle? So the width is 3. Okay, the height right here is going to be this 10.8. I'm just putting it up here so you can see how high it goes, which is going to give me 3 times 10.8. What's the width between 9 and 12? They're not always necessarily going to be the same. That's why I'm writing this out. They're not always going to be the same. And then the height we said is, so we're going to do 3 times 11.2. And then the width of this last one is 3. And the height is 11.4. Right, we don't care about this last point right here for this one. And then that's going to give me 3 times 11.4. Okay? So for the formula, it's going to look like this. Some people go right to this. They're just like, this is quicker. And like, yeah, that's right, but I want to make sure you understand this. So what do we get? I don't care. Use your iPhone calculator for all I care. Because this is just basic math stuff. So usually for these problems, they'll give you a calculator in your hand if they're decimals. If they're not decimal, they might not. So somebody help me out here. What do we get? Final answer. Someone already did it? What is it? It's beautiful, Mason. Oh, it's all in your head? I trust you, 100%. What's my units now? So let's look at the units we had. It was gallons per hour. What did we just calculate? Yeah. Oh, crap, I can't read. Mason, did you catch that too? So your answer's wrong? Okay, you said from 3 to 12 hours. Maybe you should read, unlike me. Okay, so I only care about these 3 then. So this is fake. It's fake news. Alright, redo the video. Start it over. Alright, so Mason, now what's the real answer? Any problems with that, Emily? Good. What's the units? We just had gallons per hour. We found the antiderivative of gallons per hour. So it's gallons! Yes, very good. By find the Riemann sum, since this is the rate of how much it's doing in that time interval, we can just figure out, oh, well, like from 0 to 6, this is the rate. So if we just multiply those two together, that's how many gallons happen inside that interval there. So this is going to give us gallons. So antiderivatives get rid of that per part. This per hour is gone. Okay? If this was per hour squared, I took the antiderivative of that, that would give me just per hour. If it is gallons per hour, antiderivative would give us just gallons. And if I had gallons and I took the antiderivative of that, I would call you crazy. Why would you do that? What's up?
So, would there be any difference if you were just use like the distributive formula? Because can't you just attempt to do 3 times and then...
I totally agree, but what if the intervals aren't equal?
Wouldn't they have to be?
Nope. What if this table, instead of a 9, gave us a 10? But, meh, good catch. Alright, let's move on. Let's see if I can get this problem right. Okay, let's approximate the right Riemann sum of the area of the region bounded by the graph of f of x equals 2 over x. The x-axis vertical lines, x equals 1 and 3, using 6 equal rectangles. So let's go ahead and graph this bad boy. So we're going to go from 1 to 3. It wants to give us 6 equal subintervals. Huh? That is a lot. I'm not going to lie. If it gave us two intervals, I would just use 1 to 2, 2 to 3. If it gave us 4 intervals, I'd go from like 1 to 1.5, 1.5 to 2, 2 to 2.5, 2.5 to 3. It gives us 6 though, so that really stinks. Let's do it. Well, if I put a 2 there, don't I just need 3 intervals from 1 to 2? Okay, what are my 3 intervals from 1 to 2? 4/3, 5/3. And then from 2 to 3, I'm going to have 7/3, 8/3. Okay. Anybody know what the heck this graph looks like? 2 over x. No, it's not something that cares too much. I know what this graph looks like, and I barely care about anything. You have a question, comment, concern? No. Oh, you did this, which is correct. Yeah, the graph looks like this, by the way. You should know these things. Okay? So how do we actually find out these values? Oh, you can just plug it in. So what's the height of this one right here? Oh, that's going to be just 2. Okay. What's the height at 2? Let's just make this simple. So height at 2. It's going to be 1. And what's the height at 3? 2/3. So all we're doing is just plugging this in. This one's a right Riemann sum. Okay, so which end should I start from? The right. Okay, very good. The right. So here we go. Again, these aren't the most perfect drawings in the world. So there it is. There's. Yes, I'm aware that I can't equally space things out and deal with it. Okay, so we need to zoom in here to see how bad this is. Thank you, Elio, for saying that's alright. Thank you for not criticizing me. Well, I mean, I can. And I can criticize you. You know, I haven't criticized him in a while. Neelish, how's it going? Alright, hey, let's talk about this first rectangle right here. What's the width of this first rectangle? 1/3. What's the height of this rectangle? Don't we just plug it in? Isn't it like f of 4/3? Don't we just plug that into the function? I'm going to do that in a second. I'm just going to do the formula all together here. Alright, then what's the next rectangle right here? What's the width of it? It's 1/3. What's the height of it? F of 5/3. Plus, next rectangle, what's the width? 1/3. What's the height? F of 2, which we already said that was 1, but I'm just going to keep it like this. Okay. So I can fit this all down. I'm going to just put it below here. Plus, well, you could have finished this one out, can't you? I don't have to be the one to. Try to finish out your own. If not, I'm going to have it up here. I bet you'd have a calculator for this one, by the way. But just in case, what's f of 4/3? If you plug it on 4/3, you flip the second and multiply, by the way. So for this first one, we're at 1/3 times 3/2, you said? Plus 1/3 times flip the second multiply. 6/5 plus, we know this one already. It's 1 plus, on this one right here, 6/7 plus 1/3. This one's gonna give me 3/4. 3/4. And we already know this last one, which is 2/3. I mean, you use your calculator here, or you could try to figure this out. I mean, I would just use your calculator. Mason, what'd you get? Come on, Mason. Fine, let's do this by hand. I don't want to do it by hand. 1/2 plus 2/5 plus 1/3 plus 2/7 plus 1/4 plus 2/9. So I need the GCF of 2, 5, 3, 7, 4, and 9. Which is definitely 2 times 5 times 9 times 7. Is somebody going to do this or what? We're just going to just stare at each other. No, I'm not finding that GCF. No, if you just still do the distribution formula, you still have to figure out the GCF of all those, of like most of those. You think it's right? It's better than what I got, so give me. Say it one more time. No, that's about right. Yeah, because like all those numbers are either like a half or a third, like give or take. And you're adding a bunch of those up. You have 6 of them. That's right. All right, now problems like these, they're just annoying, right? Because there's nothing to it. Like there's no like substance to it. You're just like, oh, just gonna find this area. It's annoying. Don't worry, pretty soon we can do this problem by hand without Riemann sums. And it's so much easier. I believe the answer is 2 ln of 3 is the answer, is the area underneath that curve. Bet you it's 2 ln of 3. Magic. It's a secret. I'm a teacher. It's a secret. When we get back from break.
That's a long time. I've been like 4 weeks.
All right. Let's talk about when we have unequal widths. How far am I going to go here? Wow, there's like no actual stopping point. I think I'm just going to go with this page front and back. Okay. Okay, so now if we have unequal widths, it doesn't really change much. Okay? Same idea, same thing to do it. I try to teach you a way that's going to work for every way you do it. Okay? So it says right here, let's approximate the area bounded by f of x using 5 subintervals as indicated in the chart. Assume the function is an increasing function. Indicate the units of measure. Okay, so let's go ahead and do a left Riemann sum. Do you want me to draw this one out or just go for it? Just go for it. All right. So for a left Riemann sum, pretend I'm drawing, I need to go from there to there, from there to there, from there to there, and from there to there. Actually, and from here to here, because it wants 5 subintervals. Okay. So for a left Riemann sum, am I going to start with the 1 or the 15? The 1. Okay. Okay. So for this rectangle, what's the width from 1 to 4? So again, this is my width right here I'm looking at. Right, this is the height. So this is the width. This is the height. Function is height. So it's going to be 3 times, and what's the height? Remember, I'm starting with 1. What's the height at 1? It's 2. Plus, what's the width from 4 to 6? It's 2. What's the height at 4? Because again, it's left. It's 5. Plus, what's the width from 6 to 9? 3. What's the height at 6? 9. Plus, what's the width from 9 to 11? What's the height at 9? Did I have enough rectangles? 1, 2, 3, 4. And the last one, what's the width from 11 to 15? Plus 4 times 15. That came from there. So if you notice, for the left Riemann sum, I'm using these heights. The 5 on the left. Okay? So this one I could probably do by hand. This is going to give me 6 plus 10 plus 27 plus 22 plus 60, which is what, Mason? What is it? Am I going to trust you? Hey, what would the units be for this? Feet. Is this an overestimate or underestimate? Because it says that it's increasing. So it's increasing and it's left, so it's underestimate because left Riemann increasing. That's beautiful. That's full credit. Why do more? Yeah, Jonah. Jonah's gonna write me like a whole story. Excited to read it.
Maybe he's a really good story writer.
Maybe story writing is his thing. Do you want to do the right Riemann sum as well? Sure, let's go ahead and do the right Riemann sum. Okay. Let's do it. So I'm going to start here now. So I'm going to go backwards. Okay, so I'm going to start with this guy right here. So what's the width? 4. And what's the height? 20. So now I'm using the right side. Okay, now what's the width from 11 to 9? 2, 15 plus 3, 11 plus 2, 9 plus 3, 5. Oh, there it all is. Which is going to give me 80 plus 30 plus 33 plus 18 plus 15. Which is what, Mason? 176. And this is an over or under? Because please write out the right Riemann. I'm already giving you the bare minimum. I'm sorry, but graders would have no clue what you're talking about. I just did part C, by the way. I just wanted to do it all together. Part C is already done. I was asking you what's the approximation. Is it more or less? Okay, trapezoidal. So this is the same function from the other page. For a trapezoidal, it's kind of, well, here's our rectangles we're going to draw. But this time we're going to use each endpoint. So for this first shape, I'm going to go from there to there. And this forms a trapezoid. Right? These are your bases. So the left is a base, the right is a base. So you kind of get the idea here. I'll just draw all these intersections. So this is trapezoidal. I love how we didn't even do midpoint yet. No question is asked for midpoint. So trapezoidal looks pretty gosh darn accurate, doesn't it? A little more accurate. Is it perfect? So for trapezoids, we can't really determine necessarily. The concavity actually is what's going to represent if it's an over or under, but it doesn't have that. So don't worry about that. Hey, look, it's the same question, but this time it wants trapezoidal. Do you want to draw this one as a picture? You might want this one. You might want a picture here to kind of understand it. It's going to take you more time right now, but I want you to learn it. Believe it or not, I'm trying to teach you. Even though some of you think that's not the case. Neelish. So 1, 4, 6, 9, 11, 15. Okay, so how high am I at 1? 2. I'm just gonna put a 2 next to it just to kind of help me. Maybe this is a better way to visualize it, just so it's easier to go from picture to formula. What's the height at 4? 6. I need to keep asking. You get the idea, right? I'm going to draw all these trapezoids. Again, they're vertical lines that are all perpendicular to that x-axis. We get on the picture? I told you, all today's is geometry. We haven't really done much calculus. It's the same as an even overestimate and underestimate. The only thing we've done calculus-wise is the units. Okay, so let's look at this first trapezoid. Right here to the far left. What's the width of that trapezoid? Very good, everybody. It's 3. Actually, who remembers that formula for a trapezoid before we go any further? It's base plus base. So it's the average of the bases times the width. Okay, so it's going to be 3. Can I put that over 2? 3 over 2, and then, because again, it's 1/2 times the height, base times base. Now this is turned sideways, right? So like this is base, and this happens to be the height. All right. So just I don't want to get confused when I start saying base, height. I'm just going to say width, base. How does that sound? So that we all know what's going on. So width, base. So the width is 3. What's the first base? Plus, and that's that first trapezoid. Plus, what's the width? So it's 2 over 2. First base is plus something over 2. 3. 9 plus 11. I mean, you can all read at this point. Like, I'm hoping that you all can go from here. I don't want to go too fast, but at the same time, the internet's down and I have no worksheet to give you. I know, it's very upsetting, isn't it? Yeah. The next width is going to be 9 to 11 is just 2 over 2. 11 plus 15 plus 4 over 2 15 plus squeezing it on there, 20. And quite honestly, if this is a calculator problem, you do need to show this work, and then that's it. That's a point. And then typically your answer is your next point, and then typically your units is your next point. So these Riemann sums are easily 3 out of 3s. And then they might ask if it's an overestimate or underestimate, and why. That's 2 more points. So if this is a free response, this is easily come up with 5 of the points. Our new packets are in that bin right there. Just throw away the pass. I don't care. All right, Mason. All right. I'm trying to delay it as much as I can. So, it's okay. Everyone else did. I'm still waiting. $150.5. What's my units? Got it. Okay. So I'm going to kind of skip over 6. This is just one where, like the other one before that we did, it's a function. It doesn't really give you much substance. I'm not going to really ask too much of that, so I'm not worried about it. But here we go. Here is a free response. Usually these take about 15 minutes. Let's get this done pretty quickly here. This one does not take long. Okay. Here we go. Suppose a car has the velocities in feet per second represented by the table below. So this is all in seconds, it looks like. And then it's feet. Yeah, it's feet per second. Okay? So part A, let's approximate the car's acceleration at t equals 5. Yes, you do. How do you approximate the acceleration at t equals 5? Yeah, it's average. It's going to be just the average rate of change between what two numbers? 6 and 4. Okay? So it's going to be v of 6 minus v of 4 all over 6 minus 4. And this is going to give us acceleration. Is it going to give us acceleration? I hope so. Because you're divided by time again. This is velocity divided by time. So velocity divided by time is acceleration. Okay, so what is v of 6? It's going to be 44 over 38 all over 6 minus 4. Isn't that just 3? Okay. Hey, here's the point right here. Setting it up. That's 1 point. Answer. 1 point. What's my label? That's a 3-point question right there. Okay, find the estimate of the distance traveled from 0 to 12 using a midpoint. Oh no, I haven't done this yet. With 3 equal subintervals. So that's really nice. You just need to use 3 equal subintervals. Okay? That is like super nice. So there's not many of this stuff to do. There's just 3 intervals. Okay, so we go from 0 to 2, 2 to 4, 4 to 6, 6 to 8, 10 to 12. What are 3 subintervals I can give that also give me midpoints? Because I need midpoints. So I can't go from 0 to 2, because do I have a midpoint between 0 to 2? Can I go from 0 to 4? Because I have a midpoint of? Beautiful. Can I go from 4 to 6? I have to go from 4 to, which gives me a, yay, and then the next one would be from, awesome. So as I'm going to do this, we're going to go from 0 to 4. I'm just going to try to write this out for you. Then we're going to go from 4 to 8, and we're going to go from 8 to 12. This is not work I would write down on the thing. I'm just trying to show you what the heck we're doing here. So from 0 to 4, what's my width? Very good, everybody. It's 4. And my height is actually going to be v of 2, which is 30. I'm going to write this out so you have it. Okay? Plus, what's my width between 4 to 8? And I'm looking for v of 6, because it's midpoint. Plus 4v of 10. Now, I don't care how you solve it. I really don't. If you want to take out GCF of 4, it's not going to bother me, but you do actually need to write this out. This gives you a point. Writing it out gives you a point. And Mason. $436 what? Feet? Why is it not feet per second? Okay, because we're taking the antiderivative technically, so we're finding the area.
Why do you say anti? Isn't it just the derivative?
No, it's the opposite of the derivative. So when you take the derivative, you go from f to f prime. To go from f prime to f, it's antiderivative. The integral is actually when you... I'm not going to get too technical here. Integral and antiderivative are like the same thing, but there's small syllables that makes them like very slightly different.
Can you make velocity a derivative?
You can integrate from like one number to another number, but in order to integrate, you have to take the derivative and find the antiderivative. Getting a little ahead. We're getting a little ahead. Okay, if the car travels 400 feet before recording the given velocities, how far is the car from its original starting point after these 12 seconds? It went 400, and then it went whatever we just did. How far away is it? Thank you for adding 400 to that answer. That's really it. Yeah, there's usually like a little bit more onto these, so I would say this is worth 3 points right here. This one's probably worth 2. This one's probably worth 1, and I bet you there's a 3-pointer afterwards. Okay. All right. That's it. I don't have any worksheets. Stupid internet.